Given the curve with equation e to the 2xy minus e to the y equals 100, we need to show that dy dx is 2e to the 2xy all over e to the y minus e to the 2x. In order to do that, we differentiate the equation of the curve. So to differentiate e to the xy, we need to apply the product rule. So we differentiate e to the 2x, keep the y, and then we keep e to the 2x, and we differentiate y. When we differentiate y, we get dy dx minus e to the y. So in order to differentiate e to the y, when you differentiate e to the y, we have e to the y times dy dx. The right side is 100. The derivative of a constant is always 0. This part here gives us 2e to the 2x from the chain rule. Then what we have is, we have 2e to the 2xy plus e to the 2x dy dx minus e to the y dy dx equals 0. We need to rearrange this. From part A, you see that this right side is actually a positive term in terms of 2e to the 2yx. So we are going to keep this, and we are going to move these two over to the other side, and then we just flip them, and we are good. So when we move this over to the other side, we have e to the y dy dx, and this second term becomes e to the 2x dy dx. We are not moving this, so we keep 2e to the 2xy. And we can factor dy dx so that we have e to the y minus e to the 2x dy dx equals to this right side. And now we divide throughout by the constant by the multiple of dy dx. So dy dx is 2e to the 2x times y all over e to the y minus e to the 2x. And that is what we are asked to show in part A. Part B, show that the curve has no stationary point. For the curve to have a stationary point, dy dx must be 0. Then the curve has a stationary point. In order to show that the curve has no stationary point, we set dy dx equals to 0 and show that we cannot find a point at all when dy dx is 0. Setting dy dx to 0, we have 2e to the 2xy all over e to the y minus e to the 2x equals 0. This term equals 0 only when the numerator is 0. Leave the denominator alone. 2e to the 2x times y is 0. Since e to the 2x cannot be 0, yeah, this 2 is obviously not 0, then y must be 0. Okay. If y is 0, we must be able to find the x coordinate when y is 0 on the curve. So the curve here, we see that the curve has equation e to the 2x times y minus e to the y equals 100. We need to find the value of x when y is 0. We are going to substitute y equals 0 into the equation of the curve. Where e to the 2x times 0 minus e to the 0 equals 100. Anything times 0 is 0. e to the 0 is 1. So we have -1 equals 100. And this is impossible. -1 cannot be 100. Therefore, we say that there is no curve. No, this curve has no stationary point. If it has a stationary point, it occurs when y equals 0. But when y equals 0, we cannot find a value of x. So yeah. It is required to find the x coordinate of a point P, where P is the point on the curve at which the tangent is parallel to the y-axis. If the tangent is parallel to the y-axis, that means we have a vertical tangent. And vertical tangent occurs when dy dx is not defined. Or we say that dy dx does not exist. Let's look at dy dx here. So we have dy dx equals to e to the 2xy over e to the y minus e to the 2x. This is dy dx. This is undefined when the denominator is 0. So vertical tangent occurs when the denominator of dy dx is 0. Then what we do is we set e to the y minus e to the 2x to 0. Then e to the y is e to the 2x. We have y equals 2x. Now the point P occurs when y is 2x, and to find the x coordinates of point P, we sub y equals 2x into the equation of the curve. So we are going to sub into the curve. Okay, when we sub this into the equation of the curve, we have e to the 2x, y is 2x, minus e to the 2x equals 100. Let's look at this. E to the 2x, here two common terms. We can factor e to the 2x, and we have 2x minus 1 equals 100. We need to solve for x and show that x equals all that. What we could do is we can take log on both sides, and we are taking natural log by looking at this part C here. To take natural log, we have log of e to the 2x times 2x minus 1. This is log of 100. Using the product law of logarithm, we can split this into sum of logs. Log e to the 2x plus log 2x minus 1. This is log 100. But if you look at part C, you have log 10 here. 100 is the square of 10. Then, using the power law for the first term, we can bring the exponent in front, or this is just 2x. We have 2x plus log 2x minus 1. And using the power law, this is 2 log 10. Rearranging, 2x is 2 log 10 minus log of 2x minus 1. We need to solve for x. To isolate x, we divide throughout by 2. This 2 is gone. We are left with log 10 minus, dividing by 2, we have 1/2 log 2x minus 1. So this is now shown. Part D, use an iterative formula based on the equation in part C to find the x coordinates of P correct to 3 significant figures. So we just need to solve for x to find the value of x. We have to use the initial value of 2, and the result of each iteration is correct to 5 significant figures. So if the initial value is 2 here, let's say x naught equals 2, then x sub 1, we just use this equation, and we have log 10 minus 1 over 2 log. This is 2 times 0 minus 1. So x sub 1 has a value of 1.7533 to 5 significant figures. Then we find x sub 2. So we replace x with x sub 1 now, minus 1 over 2 log of 2 times 1.7533 minus 1. That is 1.8431. Yeah, they're too far away. So we continue with x sub 3. And then we have a value of 1.8085. To 3 significant figures, this is 1.81. We continue on and do the same thing. X sub 4 is 1.8216. X sub 5 is 1.8166. So they are both 1.82 to 3 significant figures. You need 3 of them to agree. We continue with x sub 6, 1.8185. All these rounds to 1.82 to 3 significant figures. So we say that x is 1.82, correct to 3 significant figures.